Here are some examples from today's derivatives. So I think the hardest part is the planning. If you look at number 1, what you should see first is a quotient of two functions. So I'm going to be working with the quotient rule first. So I'm going to have the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator over the denominator squared. There's one hiccup in there at the part where you're doing the derivative of the denominator. This is not the square root of plain old t, which means you're going to have to use the chain rule. So let's see what that looks like. The denominator times the derivative of the numerator minus the numerator times the derivative of the denominator. So we're thinking chain rule here. The derivative of square root of something is 1 over 2 times the square root of that something, which is t plus 1, times the rate of change of that input. Well, the derivative of t with respect to t is 1, so we get a pretty easy chain rule. And then divided by the denominator squared. So I'm going to write the square root of t plus 1 squared. I'm not going to simplify, we're not worried about that here. Number 2 is pretty straightforward. That's what's the outermost thing, what you're going to have to deal with first, the quotient rule. And there's nothing too complicated when you do the derivative of x cubed. There's nothing too complicated when you do the derivative of x squared plus 1. So I'm going to leave that alone. I'm not going to write that out for you. We're finding dz dx. That might be a little weird for you, but it's not. You have an output variable z, so you can pretend like there's a y here, and everything will feel pretty normal. If there was a y there and a y there, we'd be finding dy dx. Okay, so what do you see first here? What do you have to deal with to find our derivative? You're going to have to deal with the product rule. So let's see, dz dt is going to be my first function times the derivative of my second function. And what are we going to do here? We're going to have to use the power rule and the chain rule. So the derivative of something to the 4th power is 4 times something to the 3rd power. And then our something is 5 minus x, which has a derivative, a rate of change of -1. Okay, so that's first function, derivative of the second function, plus my second function, 5 minus x to the 4th, times the derivative of my first function. So let's see, what's that going to be? The derivative of something to the 3rd power is 3 times that something to the 2nd power. Oh, off the page. And our something is x plus 1, which has a derivative of 1. Let's look at number 4. What do you have to deal with here? You have a couple of choices. You could either think quotient rule, and then you're going to have a chain rule when you get to the derivative of tangent. You could also think of this as a chain rule inside of a chain rule with 1 over something. Using the power rule, just think of 1 over x. And then the derivative of tangent inside of that, the derivative of 2 theta. So you're going to have 2 parts in your chain rule. We're going to have to find f double prime of x. We're going to do the derivative of this function twice. What are we going to do first? The first thing you deal with is the chain rule. And then when you get up here, so that's an easy derivative of 3x. When you get to the part where you're taking the derivative of 2 to the power 5x, we're going to use our derivative of an exponential function. So that's going to be 2 to the power natural log of 2. And then since our exponent is 5x instead of plain x, we're going to have to use the chain rule.